This is Dr. Mihir Shah once again with another video. In this video, we are going to learn how to draw network diagram under the chapter Network Analysis, subtopic Critical Path Method under the subject Operation Research. Again, a very important topic for all the TYBMS students appearing for semester 6. Okay, in this video we are basically going to learn basic rules concept of network analysis, and thereafter we will be taking up 6 examples. Okay, how to draw the basic network diagram. Okay, in order to solve the sum based on network analysis, the drawing of the diagram is the most important part. Okay, so in this video we are only going to cover up how to draw the network diagram. Once that is understood, in our next video, we are going to be solving each and every, we'll be taking a one problem sum which will cover up each and every type of or each and everything that can come in this particular chapter. Okay, but as of now, in this video, we are only going to prepare and learn how to, prepare and make the network diagram. So chalo, before starting making the diagram, we will be taking a few example, few rules, few concepts. So we'll clear all those, and thereafter we will start with one by one, taking up the question and seeing how to, frame or how to construct a network diagram with that. Chalo. But before learning how to draw network diagram, there are some basic concepts which are required to be understood before drawing network diagram. So now let us see what are the basic concept of network analysis. Number one, an activity. In network diagram, an activity is represented by an arrow. Example. Okay, so we can see here one arrow which has written an alphabet and a number which represents. It means that activity A takes 5 days to be completed. So always remember, while drawing a network diagram, the activities will always be represented by an arrow. Second, an event. An event represents a specific point of time or an accomplishment in the project. So in a network diagram, an event is represented by a node that is nothing but a circle. So very important point, that is example. Now if you look at the question, if you look at the example, event 1, the circle with the node 1, it represents the start of any activity. In this case, we have been given activity A, and event number 2 represents the end of activity A. So activity A starts from 1 and it ends at activity 2. Event are represented by a circle. So it means that event number 2 will occur only when activity A ends. So an event is always represented by a circle. So that's the second basic concept that needs to be understood. Third, sequential activities. Two or more activities are sequential in nature if the end of an activity is the starting point of the next activity. Example, now if you look at the diagram, we have the starting point of A, which is number 1. We have the end point of A, which is number 2. But in sequential order, the end of A becomes the starting point of B, and then we have event number 3, which is the end point of B. So here activity B starts after activity A. So whenever there will be sequential activities, okay, the starting point of the second activity will always be the end point of the very first activity. Now these all concepts are very important while drawing the network diagram. The next that we have is known as the preceding activity. Activity that must be completed prior to the start of another activity is called as the preceding activity. Example. Now in the same diagram where we have activity A and activity B, Here, activity A is the preceding activity for activity B. It means in order to start activity B, you will first need to start activity A. Now, the next basic concept is succeeding activity. Activity that cannot be started until one or more preceding activities are completed. It is called as a successor or a succeeding activity. Example, in the same diagram where we had activity A and activity B, here activity B is the succeeding activity for activity A. So activity A is preceding for activity B and activity B is succeeding for activity A. So the one which is prior will be called as preceding, and the one which is later after the preceding, it will be called as a succeeding activity. Now the next concept is concurrent activity. Activities which can be accomplished or performed simultaneously are known as concurrent activity. Example, now if you look at this particular diagram, we have activity A. The end point is, the starting point is 1 and the end point is 2. After the completion of activity A, there are two activities which are simultaneously being performed. That is activity B and activity C. This is nothing but a concurrent activity. Activity B and C are concurrent activity. It means from one single activity, two or more activities can be performed simultaneously. That was concept number 6. Next, we have the merger event. An event which represent ends or completion of multiple activities is called the merger event. Now merger is nothing but when you're merging two or more events to one single event whereby you're representing it is the end. Example, now if you look carefully here, we have activity C and activity D, two different activities, and if you look at the arrows, they have been merged to one single event, which means that's the completion of both those activities. Activity C and activity D end in event number 5. Hence, event number 5 is the merge event, where it is getting merged and that's called as the end point of that particular activities. Next, we have the burst event. An event which represents the start of multiple activities is called the burst event, the exact opposite of the previous event. Example, from single event when we have two or more activities which are bursting out, that is nothing but burst event. Example, it said that both the activities E and F start from event number 4, hence event number 4 is called as the burst event. Now, the last basic concept which is required to be understood. After that, we'll be able to easily draw network diagram. The last concept is merge and burst event. An event which is merge as well as burst event is called as merge and burst event, meaning there will be a point where it will be tapering and then there will again be a burst in that. Example, the diagram looks something like this. Now, activity C and activity D are getting merged at point 4, and at the same event, activity E and activity F have been bursted. So, event 4 represent completion of activity C and D and the start of activity E and F. So, these were the basic concepts which were required to be learned in order to solve problem sum based on network analysis or even to draw the diagram based on network analysis. Now let us start with drawing the network diagram. and learning how to draw them. Now, in this particular video, we're going to take up two examples, okay, whereby we'll be drawing network diagram based on those two questions. So let us see how to draw network diagram. Okay, now let us see how to draw network diagram for the following set of activities. Now in the question, we have been given various activities from A to H, and thereafter we have been given the preceding activity. So now let us see how to draw network diagram based on this particular question. Now the very first activity given is A, and there is no preceding activity before A. So we can say that A is the very first activity that we need to prepare. So our very first activity, number one, our very first activity is activity A. Now, always one more thing. Before making the activity or before drawing the activity, always check if from the very first start point whether there is more than one activity which have been come out. Okay, now in this case it was only one because before A there is no preceding. So we directly have made the very first activity ka diagram. Now activity B, the second one is activity B. Now activity B, preceding activity is A, and activity C, also preceding activity is A. It means from A, B and C activities have evolved. So where the point where activity A comes to an end, from there two activities have evolved. So that's basically the burst event where we have activity B and activity C being evolved. Okay, so we'll draw that now. So from activity 2, from the event 2, we have two activities, activity B and activity C being evolved. Now going ahead, the next activity is D. Now D has the preceding activity B, meaning from B, so I'll note down here point number 3, the event 3. From B, D is getting evolved, and from point C, E is getting evolved. So 1, 2, 3, and this is my fourth event. So from B, we have activity D which is getting evolved, and from fourth event we have activity E that has get evolved. Now so we have noted down D and E. Now let's check the next one. The next activity is F. Now F has the preceding activity D and G has the preceding activity E. And then you look ahead. Now I'm not making it right now because I can see further, that is activity H, which has preceding activity F and G. So now we need to plot F and G, but then if you look carefully, F and G, they both end up at activity H. So basically these are nothing but they are merging down. So now what we will do here is event number 5 and event number 6. From D we have activity F coming out, and from E we have activity G coming out. But then both of them are merging at point H. So we'll taper them down. So we'll note down here. So from D and from E, from both these activities, okay, they jump to event number 7. Now from D we have F coming out, and from E we have activity G coming out, and F and G together end at activity H. So they all combine at
activity H. So my last event is event 8. So this is how we had to solve the network diagram based on the very first quest. So very simple. So whatever activities are there, we need to note down. Before that, we just have to see the preceding activity. That is the activity from which that particular activities have evolved. Okay, thereafter we have to see whether there are, it is getting bursted into various activities or merged to one single activity. Now, in the same manner, let us try the next question. Now, in the next question is given that draw again network diagram for the following set of activities. Again, we have been given activities A, B, C, D, E, F, G, and then the preceding activities are also be given. Now, the very first activity is activity A. The preceding activity is nil, meaning there is no preceding activity. And if I look at even B, again there I can see that there is no preceding activity. So now how to start this? Now look at this very carefully. They both are going to start from point 1. Okay, because point 1 is the activity. Before that there won't be any other activities. Now from this first event, okay, two activities have been evolved, that is A and B. So we have activity A getting evolved and activity B which is getting evolved. There is no preceding point ahead of that. Okay, from A, now if I look carefully, from A C has got evolved and from B D has got evolved. So we'll just note down here, this is event number 2, event number 3. From A we have activity C which has got evolved, and from B we have activity D which has got evolved. Now looking ahead, we have point E which is evolved from C, and we have point activity F which is evolved from D, and E and F are both merging to one single point G. So it's similar to the previous sum that we have done, okay, where they are going to again merge down. So we have event number 4 and event number 5. From event 4 we have an activity E which has got evolved, and from event number 5 we have another activity, that is F, that has got evolved. They both meet at the same point, that's number 6, and they taper and they merge to one single activity, that is activity G. So the end point of this entire network diagram is 7. So this is how we had to draw the network, this is how we had to draw basically the network diagram based on the activities and preceding activities given in the question. So these are the first two sums that we have solved based on network diagram. Okay, now let us start with the question number 3 on how to draw network diagram with the various set of activities given. Now before starting question number 3, we have already completed question number 1 and 2 in the previous video. So those who haven't watched the previous video, see that you'll first watch the previous video, because in that we have learned about the basic concepts of network diagram, and then we have solved two sums based on how to draw network diagram. Once you have went through that video, then you can start with this video, whereby we are going to start with couple of few more sums in which we are going to draw network diagram. Chalo, question number 3. Draw network diagram for the following set of activities. Activities given in the questions are A, B, C, D, E, F and G, and then they are given as the preceding activities. For activity A, there is no preceding activity, so that is the activity from which we will start our sum. So number 1, we have activity A. Next activity is B, the preceding activity is A, and then we have activity C, again the preceding activity is A. It means from A, two activities have been evolved. So now we end the first activity. From A, we have activity B which is getting evolved and activity C which is getting evolved. So we'll note down B and C. This is the end point of B, this is the end point of C. Now in the questions given that from B activity D has evolved and from activity C the activity E has evolved. So from B we are noting down activity E, and from activity C activity E has got evolved. Now later on is given that from activity D activity F has evolved, and from activity E G has evolved. Now look at this very carefully. Now none of these 2 points are merging to one single point. Now we need to have a closed network diagram. So now since there are 2 different points where they have been evolved from 2 different activities, see how we need to close it now. This is event number 5, this is event number 6. From D we have activity F which is evolved, and from E we have activity G which is evolved. Okay, after that it's not showing anything else, no other activities are there, so we merge them to the last activity. So this event gets closed at event number 7. So always remember in network diagram where the diagram is not closing down, in the previous 2 sum that we had done, it used to always close down to one single activity. Here the sum didn't close down to any activity, so at the end we need to close it down into a complete network diagram. So this was question number 3, in which the last activity did not merge. So this is how we need to solve such kind of sums. Now let us start with the next one, question number 4. Again similar question. Draw a network diagram for the following sets of activities. Now many activities are given here, activity A, B, C, D, E, F, G, H, I, and then they are given us many preceding activities and merging activities. So now let us see how we need to solve this sum. Okay, first is activity A. Again preceding activity is nil, so our sum will start with activity A. Now going ahead, I can see that for activity B and activity C both have evolved from activity A. So now they're going to burst out. So from A we have 2 activities, activity B and activity C, which have evolved, which is activity so this event number, this will be event number 3, this will be event number 4. Now going ahead I can see that from activity B activity D and activity E both have evolved, but now look here, I can see here E also, from E F has also been evolved, and from C also F has been evolved. So now this is going to be merging. Okay, there is a lot of merging and bursting in this case. So now look at this very carefully. C and E together, C and E together will give you activity F, and from B D and E both the activities have been evolved. So I can see that from B E is getting evolved and E and C together are forming activity F. So now this clearly states that from B and E activity F has got evolved, and from B another activity has evolved, which is activity D. Okay, so from B we have D activity and E coming out, and C and E together will form activity F. So I'll close it down to, this is event number 5, this is event number 6. Now from activity D G is evolved, and from F H has evolved, and then G and H they both close down to I. So now this is tapering down. So from D, we have activity G, and from F, we have activity H. They both merge to form a single activity, that is activity I. So here our network diagram gets end at event 8. It started from 1, it got ended at 8. So this is how we had to solve sum based on network diagram, where complex preceding activities were given. Okay, where we were merging it, bursting it together. So this is question number 4 based on drawing network diagram. So altogether 4 sums have been completed. We have one last sum to be completed. So now let us see how to solve the last sum based on drawing network diagram. Okay, now question number 5 states that draw network diagram for the following set of activities. Now activities here are given in the form of numbers, and numbers represents the events. So they have directly given the activities based on event. Okay. So starting off with the sum, it can be seen that from event 1, event 2 is released, and from again event 1, event 3 is getting released. So we'll start with event number 1. Now from the first event, we have the second event release, and from the first one we even have the third event which is released. Okay, now from 2 we can see event 4 getting released, and from 3 event 5 is getting released. So from 2 we have event, or we can even say as activity 4. From 3 we have event 5. Now from 4 we also have event 5. So from 4 we also have event 5, and from 4 we have 6. From 4 we have 6. I'll write it in here and not this one. And similarly from 5 also we have event 6 which has been evolved, and lastly 6 is getting evolved to event number 7. So this is how we had to solve sums in which, let's say if they are given us direct numbers of events, so this is how we had to solve the sum based on the activities in terms of events. So with this we have completed 5 sums whereby we learn how to draw the network diagram. Now in our next video we are going to be solving sums based on network analysis, where we'll have to first draw the network diagram and thereafter use some formula, some method, some steps in order to get the network analysis done. I hope everyone have understood how to draw network diagram. With that, we'll be ending this video here based on drawing of network diagram. Thank you.